Guys, 1.1 is titled Variable Expressions. Mathematically, we talk about variables a lot. You're going to hear it a lot in this class all year long. Good morning, Mr. Cade. Good morning. So, show of hands quickly here. Variables, what do you know about them and how they relate to math? What have you got? Have you ever heard the expression variable? Nobody's even heard of a variable? You've heard of one, Alex?
Yeah, I just don't.
Just not sure. Okay. Check it out. As I look at 1.1, our whole focal point is going to revolve around variable expressions this year. We're going to continue to build off of that. So if we're not sure what that is, let's see if we can explore to figure out what this looks like. So how about a volunteer to read my goal for me first? What is our goal? What are we trying to accomplish here? Anybody want to volunteer to read that? Go ahead.
Evaluate and write valuable expressions.
Okay, go back on that word right there. It's a variable, okay? Evaluate and write variable expressions, okay? We need to be able to understand what evaluate means and what it means to write them, okay? If I say evaluate 6 plus 2, what are you going to tell me? If I say evaluate 6 plus 2, what are you going to tell me? 8. 8. Evaluate simply means to do what then? Add them together. Perform the operation. Tell me what it equals. Okay? Are we cool with that? Okay. So we're going to evaluate these and then write. You guys all know what it means to write. Okay, if I say write your name, you know what you're doing, right? Now confusing write with write, and that's not good. Okay, that's for the English people. They'll straighten that up. Okay. All right, so let's get rolling right here. Numerical expression here, and then we'll come into this variable stuff. But let's get rolling right here. This is the part where I want you to make sure you're filling stuff in on the notes that you have provided for you. So a numerical expression is going to be the following. I'm going to zoom up on this a bit so I have room to write. But this is going to be called a mathematical statement involving numbers and operations. So we have a mathematical statement involving numbers and operations. Do I need more time getting that down? Okay, so as an example, I said evaluate 6 plus what, guys? 6 plus 2. Let me write this down right here. What are my numbers? What's my operation? Addition, okay? It's just perform some kind of a basic operation. That's all that means. That's what a numerical expression is. Perform some kind of indicated operation. Now, our whole point behind this pre-integrated or pre-algebra class this year is going to talk about variables and variable expressions. That's the whole focal point of this class this year. What's a variable? What's a variable expression? And how are they used in math? Specifically this course. A variable, I'm just going to give you an example. How are these two related right here? How are these two related? What's common? What's alike, Alex?
You're adding 2.
You're both times adding 2. There's an operation of addition. What's different this time? Somebody I haven't heard from yet. What's different?
You don't know what X is?
We don't know what X is. We don't know what X is. We call variables and, say it again.
We don't know what X
We don't know what X is. Anytime in math we're talking about variables, we're saying, that's our unknown. We don't know what it is. That's excellent. Way to go there. Give yourself a pat in the back, all right? Or air fight him, somebody, all right? You don't know what it is. It's an unknown. That's what variables are. These are unknowns. I'm going to write that in there. That's an excellent explanation. These are unknowns. We don't know what value it holds. It's unknown. It's a letter that we use to represent a number. It's a letter we use to represent a number. Now, when you guys get into your Google quiz today with this, you're going to see some stuff like this here. Okay, so it's an unknown. You're going to ask you, what's your unknown? What's the variable? It's a letter used to represent a number. So if I come back to this right here, what is the variable? X is. Is X the only variable you can use? No, you can use anything, all right? But that's going to be a focal point for this year, okay? So then, variable expression. X plus 2 is a variable expression. Variable expression is going to be any mathematical statement that contains a what? A letter. Yep, it's any mathematical statement mathematical statement containing letters. Somebody give me an example of a variable expression in math using any operation. Got one, Caden? X plus 2 equals 8. You're taking it further. You're putting an equal sign in there, making an equation. An expression, you don't even have to have an equal sign, but I like what you're saying. You could say that the X plus 2 would be an expression. Could X plus 18 work? Is addition the only operation we're ever going to work with? Give me something different. Colton.
X minus 4.
X minus 4. Okay. Could I say 5 times X? Could I do that? Okay. Found anything. Anything with a letter in it. X divided by 12. And we'll look at stuff like this. You're going to rule with this. You're going to do a great job with this. I already know it. Okay. Then to evaluate a variable expression. What does this mean? All right. Well, let's just, I'm not even going to give you a definition. The word evaluate here, the word evaluate we already talked about. Whoa! Come on. The word evaluate means, oh boy, I did it again. Third time's charm. To evaluate a variable expression, it just simply means to solve. It just means to solve right here. So as an example, I'm going to tell you right here, solve the following. X plus 12 if X equals 6. So I'm saying, hey, here's an expression, variable expression, X plus 12. If X is 6, what's the evaluation? 18. Simply put, how'd you get that, Nick?
That's 6 times 3 is 18. 12 is 2 6.
That's excellent. 12 is 2 sixes, so you kind of broke that. That is a heck of an example. That is a very creative way to think. I like that. Or I could have just simply substituted 6 in for X and gone 6 plus 12, which is also what? 18. Did you guys catch what he just did there, which was absolutely amazing? He said, oh, well, I have 1 6 right here when I plug that in, right? And 12 is 2 sixes, so he had how many sixes total? 3 of them times 6 was, I am absolute, that's awesome. Good job, way to go. That's awesome. So if you evaluate something right here, evaluating a variable expression basically means to substitute this in. So this really becomes 6 plus 12, which is what value, kids? 18. Awesome, guys. You're going to rule with this. You guys are going to do just fine today. And then the last thing is a verbal model. You're going to hear me say, what's your verbal model look like? Okay, Mr. Slater said I had bad what this morning? Anybody catch that word? Well, bad jokes. Bad, what was the word? Bad verbiage. Okay, I have bad verbiage. All right? So we're going to use things called verbal models. Okay, so verbal models work kind of like this. A verbal model basically is using words to solve problems. Okay, here's the deal. There's a bunch of people in this room right now, right? There are some girl students, there are some boy students, and there are some teachers in here. Would you agree with that? Would you agree if I took the number of girl students plus the number of boy students plus the teachers that are in this room, that would equal the number of people in this room? That's what we're really saying. A verbal model is just like saying, okay, if you want to know the answer to something like this, sometimes you can put it in words. So, as an example, I'm just going to say the number of boy students plus the number of girls, we're going to use the words right here, plus the number of teachers right here, equals the total number of people. So who would count the number of boys in here for me quickly? Who's got that? Ray, you want to count that for me? Somebody count the number of girls in here for me. Who's counting the number of girls for me? Bristol, will you do that for me, kiddo? Slater, will you count the number of teachers for me? Very good. Number of boys yet, Braden? 14. Bristol, the number of girls, kiddo? 11? 7, I'm sorry. That's going to total number of people within this room right now, shouldn't it? What's that going to add up to real quickly? Evaluate the number of people in here based on that verbal model. How many people are in here? 24. Okay. Hey, NASCAR fans in here? Nobody? Am I the one? You are, Braden? Okay, you guys NASCAR fans? No way. 24 obviously synonymous with who? Jeff Gordon, but right now, who drives a 24 car now? Chase Elliott, right? Doesn't he? Yeah, he does. He does. All right. Very good. All right, so that's the vocab we need to get through. So let's get to the meat. Let's get to this right here. I think you guys are going to get this. It says evaluate the expression 3 times b when b is what value? What's your b value here, guys? 90. So it says basically take 3 times what here, guys? What are they asking you to take 3 times? 3 times 90. So to evaluate this b gets replaced with 90 right there. So to evaluate this expression, 3 times 90, what is that value? Nathan? 270. Very good. Okay, let's try another one. Evaluate x plus y when x is what value, kids? 9, and your y value is? Okay, so this is really going to become what plus what? 9 plus 5, which is? Substitute it in and solve, and you're going to get 14. Okay, you guys take a minute and try those 3 right here. What's your x value, guys? What are you using for x in these on your own? 8. What are you using for y? Okay. I'm a firm believer that people, and kids especially, learn really well when they have the opportunity to talk back and forth, especially when you disagree. I think disagreeing about stuff offers the best chance for learning. So when you get your 3 answers, check with the neighbor around you. If you disagree about your answers, talk to each other, okay? So try those 3 on your own. Any more time? Show of hands on my first one. Colton, run with it. 20. How many agree 20? 8 plus 12. You got this. This is the same as 8 plus 12. Turns to 20. Awesome. Second one, x minus y. Who's got that? Run with it, John. What'd you get?
6.
How many agree with 6? Okay, and then the last one. Who's got the last one for me? Bristol, kiddo, what do you got? 4. How many have 4 there? Okay, this is not difficult. You're simply substituting and evaluating, all right? I think we get this. You know what a variable is. You understand how to evaluate. Somebody read the goal up in the beginning of the notes. What were we asked to do? We've accomplished the evaluate part. You substitute and solve to evaluate. Now the part that's going to get maybe more difficult is to do what with variable expressions? Not evaluate them, but what the goal say? Evaluate and what? We've got to work on writing these. Okay. Now I really messed up your notes, and I apologize for this, but right down here it says common words and phrases that indicate operations. Okay. You might want to say right here, look on the second page, or look on back for this. Look on the back. Okay. So maybe jot that down on your notes, look on the back. Okay. And let's head to that next page on the back and take a look at this. So some common phrases for, what are your 4 most basic operations in math? What are they, Nathan? Addition, subtraction, multiplication, and division. We all agree with that? Okay. So some phrases right here. I need to bullet these right here a little bit. Addition. Another phrase for addition is called the sum of some numbers. So the sum of, if I say the sum of 6 and 4, the word sum means what, guys? Plus means addition. Increased means addition. Total means addition. What if I say something like 4 more than 6? 4 more than 6. What's that answer? 10. 4 plus 6. Addition again, right? These phrases are tip-offs to you for what operation to use. Okay? I'm not going to go through them all. In subtraction, you have them all over here. Multiplication, you have over here. The one that's pretty typical of multiplication, this one's pretty important right here. Product. The product of 2 numbers means to multiply. What's the word they use for division? The quotient. Okay? We call it the quotient. Okay? So let's see if we can't use that chart up here maybe to write some variable expressions. Variable expression meaning it has to have what in it? What's a variable again? What is a variable again? Right? Has to have a letter in it, okay? So if it says write a variable expression for the following phrases, noting that some number means use what? Okay? So down here we're saying there is some number out there that we don't know. It's unknown. There is an unknown number that we're going to increase by what? 9. Okay, watch this right here. That number that we don't know right there is going to be our unknown. Which variable do you probably want to use for it? You can use x. Most people use x. So I'll use x. That number. Okay. Then you have that phrase, increased by. Well, guys, increased by falls where on the table? Bristol, where's it at? It's addition. So a number increased by how much? That verbal statement right there, or that verbal model, if you will, is now written as a variable expression. There was some unknown number, x, that we increased by, added 9 to. That's what the variable expression looks like. Okay? Anytime you see the phrase a number, substitute what in for it? X. That's your unknown. Okay? You guys try problems. Try number 2. See what you come up with for number 2. It says the quotient of 9 and a number. I want you to be careful on this one. result, solution, thoughts? What do you think, Nick?
X divided by 9.
Okay, I want to be very careful on this. How many have x divided by 9? Anybody have anything different than that? Run your name by me again, I've forgotten. Gage, run that by me, sorry about that.
X divided, well, 9 divided by x.
Okay. This is a great discussion to have right now with you kids. I want to do something over here on the left quickly. What's that equal? 6. What's that equal? Whoa, 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 whoa. Duh, Parson. How about that? What's that equal? So when I add, does the order matter? How you add? Here's a question for you. What's that equal? 4? Negative 4. Does the order and subtraction matter? Yes. Okay, so watch this right here. If I went 3 times 7 right here, what's that going to make? How about 7 times 3 if I switch the order? 21. We're okay there, right? How about if I did this? 6 divided by 2. What's that equal? Is 2 divided by 6 also 3? Or is it something smaller? It's like a fraction, 1/3, isn't it? So here's the deal. Under division and under subtraction, you've got to make sure the order is correct. I have 2 answers up here that look like they're alike, but can we assume they're both right? We just said that the order on division, using the same values, in this case 6 and 2, would be different values. So this means that these would be different, wouldn't it? So which one's correct up there? This can help, I think. In this problem right here, this is kind of a tough one. We know that we're doing quotient, so we know what this part right here means. What operation? Dividing. The quotient of, okay, what was listed first here when I did that? Was the number or the variable listed first? Number. And then a number here was my variable. So which of these two is going to hold true? Is it going to be, if 9 is listed first, is it going to be the first one or second one that we want here? Second one. Okay. If I would have switched this around and set the quotient of a number in 9, then it would have been x divided by 9. Okay. So Nick, back to you. You okay with that, kiddo?
Yep.
Okay. You're on the right track. Just make sure we're good there, okay? All right. Hey, last example here, and then I'm going to turn you loose on some things today. It says you have a 350-page manuscript that needs to be edited very quickly. You are going to divide the number of pages to each editor. It says use a verbal model here to write a variable expression for the number of pages given to each editor if you know the number of editors. This is 350 pages long. Before we can leave today, we need to edit this, make sure everything is printed correctly, written correctly. Now, if that was our task today, what do you think I would probably tell everybody to do? How do you think we would do that most efficiently? Haley, what do you think, kiddo?
Like the number of pages in that textbook divided by the minute of people in the grade.
So the number of people in this room we already found out was how many? 24. Okay. So you would take the total number of pages in here and divide by? Awesome. Do you guys agree with her? You guys all agree with her? I agree. Excellent, Haley. So yeah, take the number of pages that you have and divide it by the number of. Haley, you know what you've just done? You provided us with a verbal model. A verbal model means explain to me what you're going to do. Explain to me what you're going to do. Okay? So, this is what I would tell you to write down right here. Oh, why do I lose that pen all the time? I'll just do it this way. No, I won't. I need the pen because I'm recording. Where's the pen? There it is. You said take the number of pages, right? Okay, so you would take the number of pages and divide it by the
Number of people.
number of people. And I'm going to go ahead, since we're editing the book, we're going to call them number of editors. Is that okay?
Yeah.
Okay. Now, we provided this room as an example, and in this room, we were able to count the number of editors in here, right? But in that problem up there, did they provide you with the number of editors at all? They don't, okay? So this part right here, you've already provided a verbal model. This part is the verbal model. Explain to me what you're going to do. That's what verbal model means. Tell me how you're going to solve this. If I say, what's your verbal model? Where's your verbal model? That's basically writing down how you're going to solve this. All right, so Haley, I'm going to pick on you. Is that okay? Since this is your problem right now?
Yeah.
Haley, in this problem right here, do we know how many pages we have then in order to write a verbal now, or I'm sorry, write a variable expression for this? Do we know how many pages we have?
It's a 350 page.
So to turn this into a variable expression, we would take the number of pages, which is 350. Now, anywhere in the wording up there in that problem, do they tell you how many editors you have?
No.
The number of editors in this problem is unknown. So we're going to use a letter in there. So what letter should we use to represent the number of editors?
X.
X. I'm going to use a different one. I'm just going to use E, where E stands for the number of editors. Is that okay?
Yeah.
Okay. Now, if this problem pertained to our classroom then, what value would we plug in for E to determine how many pages each editor would have to edit? How many people were in the room? 24. So you would plug 24 in for E, and that would tell you how many pages each editor has to edit. Okay? So would you want your room to be full of people or not many people at all to edit that? Well, it'd be full. You don't want to edit a ton of pages. Okay? That's excellent, you guys. Way to start the year. Way to start. Okay? I guarantee you stay on track with stuff like this year, you guys are going to have an awesome year. Okay? Questions about the notes at all, first of all? Anybody? Okay. I'm going to stop recording this right here.